Hi, in this video we're going to talk about a seemingly mundane topic about labeling various either carbons or nitrogens in a molecule as either primary, secondary, or tertiary. So tertiary. All right, and the symbols are 1 prime, 2 prime, and 3 prime. All right, so where do we go from here? Um, let's go definition, and we'll talk a little bit about why. Well, in a hydrocarbon, we have 4 bonds around each of the carbons, and hydrogens could be in those locations, or we could also have other carbons. Let's draw a simple molecule. How about propane? There we go. Now, if you take a look here, we have carbons on the ends. These are called terminal carbons. They're on the outside, the ends. Okay. Now, each of these terminal carbons are bound to only one carbon. So if you have a carbon that's only bound to one other carbon, it's going to be a primary. In the middle here, okay, we have an interior carbon, and it's bound to the one on the right and the one on the left. This is secondary. It's bound to 2 different carbons. I guess you can see where this is going now. Now we could have a case where we have a tertiary carbon, where this carbon bound to the center carbon, and instead of a hydrogen on top and a hydrogen on the bottom, we'll put a carbon on top. Okay, so we have three terminal carbons here. They're all primary, but this guy is bound to 3 of these. This is going to be a tertiary. There is in fact what is known as a quaternary carbon. I'll draw it in red in the upper right here. It's bound to 4 carbons, and I'll just leave out the hydrogens here. The central carbon right here has 4 carbons around it, and this would be quaternary, a quaternary carbon. However, this isn't going to be very interesting to you because since it's bound to all 4 carbons, it's not going to be bound to any functional groups, and really you're not going to see or need to know much about it, which is why I'm just giving it to you as an aside. Going back to my green pen. Now, let's talk a little bit why we need to know these. Especially in week 6, when you're going to be talking about reactions between functional groups, especially oxygen-containing functional groups for oxidation and reduction. The cheat sheets that we give you are really going to rely on you to be able to know whether this is a primary carbon, a secondary carbon, or tertiary carbon. Well, primary and secondary usually. And if you can be able to pick out, hey, this is primary, this is secondary, you're going to save yourself a lot of grief in trying to figure out what the reactions are to those oxidation and reduction reactions. All right, because we have examples here, but we don't have any functional groups. Well, let's put a functional group on. How about CH3, carbon there? How about an alcohol and another CH3? All right, so here we have a carbon with an alcohol group on it. Remember, this is alcohol right here, and it's off this carbon. This carbon here is a secondary carbon, so this is going to be a secondary alcohol, an alcohol on a secondary carbon, and it behaves a lot differently than a primary alcohol, where this oxygen is on this carbon only is bound to 1 carbon. This would be a primary alcohol, okay, because the alcohol is on a primary carbon. Okay, so hopefully you can see that, see where we're going with that. And this also holds true for nitrogen functional groups, and nitrogen being in hydrocarbons as well. But nitrogen, because it can bond to multiple things and sometimes takes the place of carbon in the molecules, we actually look and see how many carbons the nitrogen is bound to. So let's look at a typical amine. CH3, CH, CH3, CH3, let's get rid of this H. And H2. So here's an amine bound to this carbon. Well, how many carbons is the nitrogen bound to? This nitrogen is bound to the central carbon. And even though this is a tertiary carbon, the nitrogen is only bound to one carbon. So this is a primary amine. Okay? Unlike other functional groups, nitrogen is a little different. You count for nitrogen, count the number of carbons bound to it. Okay. All right. Well, we can also have a secondary amine. Here we have a dimethylamine, and we have 2 carbons bound to this amine. So this is going to be a secondary amine. All right, you could also have a tertiary amine if we have it bound to 3 carbons, and we're not going to be able to do anything more than that because carbon or nitrogen only has the 3 lone pairs of electrons. And this would be a tertiary amine. So remember, for carbons, it's the number of carbons that the carbon is bound to. For nitrogen, it's the number of carbons it is bound to. And if we're talking about a functional group on carbon, it'll be the carbon that that functional group is bound to for its primary, secondary, and tertiary. But like I said, this is going to be critical. Not critical. This will help you a lot if you can follow this and see it when we come to week 6.